Welcome back. This is part 6 of chapter 3 videos. In this video we will introduce another form of looping called the do-while loop. This loop is different from the for loop and the while loop in that it follows a pattern that says repeat some action, then check. So it's called a post-test loop. The flowchart indicates that the body of the loop is executed first, followed by a test to repeat the body of the loop. So that unlike the for loop and the while loop, where it is possible never to execute the body, with a do-while loop, the body is executed at least one time. The syntax of the do-while loop is important. The key word is do, followed by a block, followed by the followed by the while keyword, followed by a condition, very important, followed by the semicolon. Right? There are two major uses for the do-while loop. One is input validation, and the goal of input validation is to ensure that inputs are valid before the program attempts to use them. The second use is for menu-driven programs, such as the ones you'll have in upcoming assignments. So the data validation pattern is simply prompt for and read an input data, then check the validity of the data. Validity can be defined a lot of different ways, but generally the problem will tell you what the rules for validity. If the data that, once you check for the validity, if the data is not valid, that is, if the data is invalid, then we must repeat the process of asking for the data, reading it, checking it for validity. So it is possible for you to repeatedly ask for the input until a valid one is entered. Once a valid input is provided, the loop exits and you continue with the processing of that input data. So here is the pattern. The repetition pattern is really read, check, read, check, read, check. And notice that we're checking not for valid data, but we're checking for invalid data. If the data is invalid, it is necessary to read it again. So the pattern, read a number. If the number is not valid, read another number. So we say read, check, read. What happens here? We check again, we read again. We check again, we read again. So here's an example. In this case, let's suppose that validity means that the number must be less than 15. So what's required? Let's think about it. We must read the data, check to see if it is not less than 15. If that is the case, we must read it again, check it again, and so on. So this is written as a do-while statement. The loop begins with the word do. We have the body of the loop. What does the body do? Notice when it's input validation, the body reads the data. What is the check? The check is being performed here. What check are we doing? We're checking to see if it is invalid. So num less than 15 means valid. So what means invalid is the negation of that. So we saw earlier that negating a less than operator gives you a greater than or equal to operator. And the pattern again is read, check, and finally when the check fails, we terminate the loop. In this case, when the check fails, it means it fails because it is no longer invalid. Let's take a look at some code. Let's run this and see what's going to happen. again, if we look at this, we want to enter a negative value. So our rule for valid means val must be less than 0. We're checking for invalid, so what are we using for our invalid condition? The negation of val less than 0, which is val greater than or equal to 0. At the acceptance of a valid input, we're going to display that input. So let's go ahead and run that. Enter a negative value. We type in 4, 7, 0, minus 2, and it accepts the minus 2. Now, notice that we could have accomplished the same thing with a while loop, but let's take a look at the difference. Notice that the read statement must be repeated in a while loop. And again, the primary use of a do while is in input validation, because you always have to read once. So this will suffice, but it is certainly not advised. So we don't advise that. Now let's do a validation that's a little more complicated. What is going on here? We want to enter a number that is within a range 1 to 100 inclusive. So what does that mean? It means that valid means the number is greater than or equal to 1 and the number is less than or equal to 100. Invalid means the negation of that. If you remember De Morgan's law, how do we negate? We negate number greater than or equal to 1 by changing the operator. Greater than or equal to, when we negate it, becomes a less than. Number less than or equal to 100 becomes a greater than. The and that we have becomes an or. We saw that in an earlier slide. All right. So the code would look like this. You could also do it with a while loop. Again, we do not advise that because you're reproducing code. Okay. Now let's take a look at another example. And the goal here is to read and validate two inputs that satisfy the rule. Two inputs that satisfy the rule. One value is negative, the first value is negative. The second positive. Right? So the prompt says enter a negative value followed by a positive value. We'll read two values, and then what are we expecting? We're expecting num1 is negative, so we must negate that. So num1 is greater than or equal to 0. We expect num2 to be positive, num2 to be greater than 0. To negate that, we must say take the greater than and make it a less than or equal. The rule says that these two things must be true, so this is an and. So we must negate the and produce an or with that. All right? So let's see how that executes. Negative value. So let's suppose we have -5 and -5. That's not valid, so it's asking again. -5 and 0. 0 is not negative. We can say 0 and 5, not negative. So we got to say -2 and a +3. And it accepts it. Okay? Now, finally, we said we can use the do while loop for a menu-driven program. It's really important that you understand this pattern because all menu-driven programs have this basic pattern. It's a do-while loop. You repeat the program until the choice to quit is made. So let's suppose that for this program, typing in the letter Q means quit. So we are saying until the user says quit, display the menu and read the choice. Then we perform the choice. A menu-driven program again says A means do this, B means doing that, C means doing that. So we have a switch, and this is the appropriate use of a switch for a menu-driven program. Each choice leads to some actions, and the switch structures that for you. So this is the pattern for a menu-driven program. Now let's take a look at one. It'll get a little complicated, but let's take a look. Okay. Clearly, our menu gives the user 3 choices, and one of the choices is to quit after saying adios. So the program looks like I need a variable from a choice. I need my loop, do, open, block. And down here we say close block and while menu choice is not equal to quit. And in between we have displaying the menu, reading the choice, and the switch that is used to perform the choice. Notice that we're using the function to upper. And what to upper does, it takes the character menu choice and turns it into its uppercase equivalent. So if you type in the lowercase a, to upper makes it the uppercase a. Alright, so here's the program. Let's run it. See what happens. Here's the menu. I can say quit, and it quits. I can run it again. I can say capital Q, it quits. So uppercase and lowercase letters are treated the same. Now I can say A, I can say B. Notice that when I say A, here is the output. When I say B, here is the output. And the menu keeps coming back until I say quit. Okay? Let me show you one more time what this program looks like. Take a good look at it. Display the menu, a switch to process the menu, and all of that is enclosed inside the body of the do while loop. Okay, with that we're going to terminate. We have one remaining video, and this on nested loops.